Hello, this is Richard Jacob for Matrix Science, and my talk is LFQ for the masses. It's a Mascot Distiller label-free quantitation tutorial. Within the Mascot software ecosystem, we can perform label-free quantitation using several different methods. Today, I won't be talking about spectral counting or MPI methods, just those that use extracted ion chromatograms or XICs of the precursor peaks. In Mascot, we perform identification-led quantitation. This means that after peptide identification, we go back to the raw data to calculate their XICs. That way, we don't waste time quantitating peaks that might be present in the data but remain unidentified. There are two Mascot Distiller label-free quantitation methods that we can use: the average method and the replicate method. There have been some improvements to label-free quantitation in Mascot Distiller Release 2.8, particularly for the replicate method. Overall, Mascot Distiller is faster than earlier versions, and there have been lots of general improvements to the application. Please go and watch the new features in Mascot Distiller 2.8 talk to find out more. Updates to Mascot Distiller are currently free, so I recommend installing the latest version to take advantage of these improvements. Let's start by processing a dataset through Mascot Daemon to create a quantitation summary table or report. This feature was introduced in Mascot Server Daemon 2.7, so I will be brief. Set up the Mascot Daemon task as per normal. When configuring the Mascot Server search parameters, make sure you set the quantitation method to average MD. This is very important. We want to quantitate the files independently and summarize the results, and the average method allows that. When you start the task, Mascot Daemon will process raw files and search the peaks serially. The search results are then returned to Distiller and quantitated. Once the task is complete, we can start the quantitation results export process, which is detailed in last year's Quantitation Summary presentation. You can open the result file in a text editor like Notepad, but it makes more sense to view it as a spreadsheet in Excel. For further statistical analysis, you can use Excel, R, Perseus, or some other software. Again, previous presentations and blog posts have some examples. Now we are going to look at processing data in Mascot Distiller directly using multi-file projects and the replica analysis method. With Mascot Distiller version 2.7 and earlier, a multi-file project was created and the memory efficient box had to be left unchecked. Mascot Distiller would open all the files in one big project and process them together. For the search and quantitation steps, you must use a quantitation method of the type replicate. Depending on the number of the files in the dataset, the processing and quantitation steps could use quite a bit of RAM. When it came to quantitation, Distiller would use a global elution time delta to look for peptides identified in at least one of the files in a dataset, but not in others. In Mascot Distiller 2.8, we now process all the files independently. The memory efficient box has been removed, as well as the elution time delta variable, which has been replaced by a new global time alignment algorithm. This algorithm builds a consensus dataset by aligning the total ion chromatogram, TIC, of each raw file and carrying out a rough alignment. This is then refined with further calculations to create a time shift for the individual file at different retention times and M/Z. Files are then compared using the consensus data as an intermediate. The resulting algorithm can process the datasets in parallel, which is faster and more memory efficient than the older approach. You can see the time shift values in the XIC window for a quantitated peptide. Zooming in, we can see the difference reported in seconds for each file. For the rest of the talk, I'm going to use a dataset that I obtained from the Pride repository. The dataset I selected is from a publication that looks at the role of Alanyl-tRNA synthetase in S. cerevisiae. Amino-acyl-tRNA synthetases are essential enzymes linked with neurological disorders in humans. The publication shows that the mutations have more general effects in yeast on the amino acid control pathway and heat shock response. The initial experiment looked at 3 yeast strains, 2 of which have mutations in the Alanyl-tRNA synthetase. The cultures were grown at 30 degrees Celsius, sampled, and then increased to 37 degrees Celsius for 2 hours before sampling again. Each strain and temperature condition was sampled 3 times as biological replicates for a total of 18 mass spec analysis. Rather than process the full dataset, I selected just the files for one condition, a comparison of the wild type to the C719A mutant strain at 37 degrees Celsius, as this was featured in the publication. Note, at this point I created a replica quantitation method for the analysis on the Mascot server ready for searching and quantitation. We can set up label-free quantitation in Mascot Distiller as a multi-file project. After the dataset is open in Distiller, choose Process and Search to identify the peptides. Set up the search parameters. I like to customize the quantitation method on Mascot server prior to the search. When the search is complete, the next step is to quantitate the dataset. Once quantitation is complete, the results are ready for further analysis. There are 5 new statistical analysis reports included with Mascot Distiller. These reports are generated by Python scripts and cover ANOVA, hierarchical and k-means clustering, principal component analysis, and volcano plots. There were also some quality control reports and the pre-existing tables and HTML reports. We are going to follow along with the publication and create a volcano plot. Go to the Analysis Reports menu and select Volcano Plot. Step through the dialog boxes, set in the protein ratio significance threshold. I left it at the least stringent default values, p less than 0.05, which is the same as used in the publication. Filter out hits from the contaminant database, primary trypsin in this case, and choose the output format. SVG is a good choice as it can be scaled without losing resolution. PNG is good for pasting into simple reports or for use online, and the interactive JavaScript report allows you to mouse over points in the graph and see protein accession numbers. I've selected interactive JavaScript. The report is generated and saved to a temporary archive. Move the archive to a project folder, uncompress it, and open the HTML page in a browser by double-clicking on the file. Here is the report from Distiller. The icons at the top right allow you to zoom in and interact with the plot. You can move over the data points to see the protein accession numbers, ratio, and p-values. We use Plotly as the graphing library to create these plots, and there is also an option to open it in Plotly for further editing, where you can add annotations. I have annotated 4 heat shock proteins and a chaperone that are all downregulated in the same pathway or were highlighted in the study. 4 of these proteins are shown in this table. The 5th is further down the table with a higher p-value. They have some of the most significant changes in expression when the Alanyl-tRNA synthesase C719A mutant S. cerevisiae strain is exposed to higher growth temperatures for 2 hours. The paper suggests that Alanyl-tRNA synthesase C719A mutant has an editing deficiency which causes misincorporation of serine into alanine positions in the proteome, leading to a cascade of misfolding and degradation events of key regulatory proteins. Heat stress exacerbates protein misfolding and results in loss of function for key factors in the carbon metabolism, heat shock response, highlighted here, and protein synthesis pathways. If you want to do further analysis beyond the reports included with Mascot Distiller, the data can be exported as a stats package. When the export is complete, unzip the archive. and open the protein file in a third-party analysis program like Perseus. The files exported from Mascot Distiller include a column type row, which Perseus uses to correctly assign the columns during their import, making it a one-click affair. You could then use Perseus to annotate the results with gene ontology and keg pathway information, or carry out other statistical analysis. This is the end of the tutorial, which covers the basis of label-free quantitation in Mascot Distiller. If you have questions on how to analyze your data with Mascot Server and Distiller, please contact support@matrixscience.com.